Okay, let's look at this Kedah trial paper 2. We have the diagram 5 that shows the position of the teachers, G, and the students in a class. Okay, so from here, the desks of the students A, B are at a distance of 4 meter and 8 meter respectively from the teacher's desk G in the direction of GB, which means they are on the same straight line. So let's just sketch this way. The usual vector diagram that we see so that it's easier for us to think. So this is A, G to A is 4 meter, A to B is 4 meter. Why? Because GB is 8 meter. So from here, the vector GA is the same as the vector AB, same direction, same magnitude. They are all in 4 meter. And in terms of the length, GB equals to 8 meter. Okay, and then we have another line. One is C, because the distance of students C and D are at 4 meter and 6 meter from G in the direction of GD. So direction of GD. So let's say this, this is D. And therefore we will have GC 4 meter and C to D, because G to D is 6 meter, therefore this one must be 2 meter. So from here, we know that GC GD equals to 6 meter. Then, by using the A, vector A, represent 1 meter along the GB, vector B representing 2 meter along the GD. So you look at this, every 1 meter, the vector is A, which means the GA equals to 4A. Okay, AB is also 4A because every 1 meter is represented by the vector A. Therefore, the vector G to B is 8A altogether. And as for the along the GD, every 2 meter is 1B. So from here, we know that G to C, you got twice of 2 meter, so twice of B. And C to D is just 1B. So G to D, all in all, will be 3B. Okay, and then we have GE equals to GF. Now GE, let's say it's somewhere here, E is here. Where is the F? Not sure. Let's just simply put like this. G to E is 2 parts. G to F is 3 parts. Therefore, E to F is just 1 part. And then we have BF to FD. B joined to F and joined to D. They are equal in length. So with this, let's find, using the vector A and B, find BD. So A part 1, B to D. Let's look at the diagram. B to D, basically, we have from B that go through the G, go through the D, because after all, we have this. Okay, so BD, basically, it is equivalent to B to go through G, from G, go to D. So I have GB. So BG, opposite direction, negative 8A, and the GD is 3B. So this is the answer. And next, we need to find EF. Okay. Now, in vector question, we may need to use the vector that we found previously. Now, EF is here. It's from here to here. So we start with E, let's end with F, but there is no A or B that that is known between the E and F. But we already found BD. B to D, since B to F, it is actually half of BD, isn't it? The distance. So we know that BF equals to BD, and therefore, in terms of vector, the BF, it will be half of BD. EF, basically, it is 1 out of 3 of GF. 1 out of 3 of GF, because one part out of the total of GF, okay? And then from there, GF is GB plus BF. Okay, I think that will be much easier. And we know that BF is actually half of BD. So 1/3 of, now GB, where's GB? GB is 8A, and then plus with half of BD. And what is half of BD? We can just open this bracket first. 8 over 3A plus 1 over 6. Now BD is negative 8A plus 3B. So let's combine the A with the A. So we have 8 over 3A minus 4 over 3A and plus 1/2 of B. Yeah, multiply 1/6 in. So over here we have 4 over 3A and then plus half B. So this is EF. Okay, and next, let's move on to part B. The B is such that given the straight line AE is parallel to straight line GC, AE parallel to GC. If it is parallel, therefore the vector must be also parallel. The distance between desk A and E is 2 meters. A and E 2 meters. A and E is 2 meters. Let's put this one in the diagram. A and E is 2 meters. And then we know that A to C is parallel, AE is parallel to GC. AE parallel to GC. Sorry, it should be like this. Okay, when we have the parallel line, we will have the same angle here. This angle and this angle here. Alternate angle. Okay, whether it is useful or not sure. Let's look. Find the area of ABE if the area of GBC is 25. So area of GBC is 25. We have to find the area of angle of triangle ABE. Okay, so let's look at the triangle GBC. GBC okay, the triangle GBC, and then the triangle ABE. I need to find the A, B, and E. Triangle GBC. Okay, and the triangle A, B, and E. All right. Now, I am not really sure whether the BC it's parallel to the BE or not. It never mentioned in the question. Does it mention? No. So let me just do something like this. Okay, I assume they are parallel here. They're parallel here. Okay, and then up to the C, up to the C. G, B, C. They are parallel. So this one is 4 meters. Okay, and then we need to look for A, B, E. This is 2 meters here. This is E here. Okay. And I have this 4 meter here, 4 meter there. Now I cannot assume that B, E, C, they are on the same straight line because the question never asked me to prove and I don't want to spend time to prove. So one thing that we do know, if this one is parallel to this line, okay, the transversal that they share, the transversal that connect this two parallel line is GAB. And therefore we have the same angle here. We have the same angle here. And then to find the area of the GBC, we just need to take half times the A, which is this, B sine C. So half times the A, which is 8 meter, B, which is 4 meter, sine C. Let's call this alpha. These two are the same thing, sine alpha, equivalent to 25. Okay, therefore, let's simplify this. So sine alpha equals to 25 over 16. Bring the 4 and 4 over 16. Now, next, the triangle, the area of triangle ABE can be found by using half. Again, we shall use the half AB sine C way. This is the A, and this is the B, because I want to use the angle sine alpha. Why do I use the AE? Because we were given that is 2 meter, yeah, and therefore our A is 4 meter, B is 2 meter, and our sine alpha is the same as 25 over 16 as we have found the above. So 4 times 25 over 16 simplified. So the answer is 25 over 4 meter square. That's it. Okay. That's all.